All right, let's get started. Hi everyone, this is the presentation of my final project. Again, this project is about to represent the gas molecules move, a kinetic move in the space. So I'm using this project majorly for education purpose of chemistry and representing the micro view of gas molecules kinetic move in a certain container. As you can see here, this is my UI, and it is generated from Greenfoot, which is my major utility. And I'm going to use Java as my programming language. So let me introduce how to run my project. So from Greenfoot perspective, you need to click the Run button to active Greenfoot. And then here we firstly click the Start button. It will ask you to input the initial value or parameters of this program. So let's give temperature as 25 and the pressure as 1 Pascal as a standard pressure of air, atmosphere, I mean. So these two are the major parameters which will influence our gas particles move, but nothing happened yet at this point. We still need to load our gas particles. So here let's choose oxygen as our sample and click this button. So it will load 10 oxygen molecules and it's moving following the kinetic way. So as you can see, each particle represents a oxygen molecules. It's bouncing with each other and bouncing the wall and moving in this container. Also, we can try to load some other type of gas particles like water vapor. So as we can see, since the water has the more light molecular weight, so in the same temperature and same pressure, it moves faster than oxygen. We also have some other sample like carbon dioxide. It's heavier than this two, so if we load that one, we can see a bigger gas particle got loaded and it's moving even slower. So within this container, we can observing how the gas will move from a microwave. And during this process, the program will keep recording the energy, kinetic energy of overall of this container and calculating the average speed of each gas particle as we want to achieve in this project. And if we click the button, if we click D, D stands for display the result on the keyboard, it will show you the current captured data, which is calculated behind the screen. So in the Greenfoot, it's divided into two major types, which is Word. It controls it as a container, controls the background and the logic behind the things. Actor is the objects that we play within the project. So I do have actors as button. So each button would trigger its functionality like load gas particle, enable heater. So if you click on that, it will ask you to provide a final temperature. Like here, we're starting from 25, and we want the heater to heat the container up to 300 degree. So it will slowly heat things up, and consequently, it will make the gas particle move faster. Gravity, similar as gravity. So also data display, it's a label. I will show display all the labels data and other data. Uh, drop down list, drop down item, gas particle, or other items that we want to control in this project. So of course, if we give a higher temperature, like 100, and the pressure we want have 5 pascals, as much higher than the real nature atmosphere, we can also achieve that. It's like we heating the container and give higher pressures. Still, we choose oxygen and load gas particle. As we can see, it's move magnificently faster than it should be. Well, than it used to be, as it should be. Sorry. So also let's try the water and also the carbon. Oh, well, let's try Bethany, the special one, the biggest one. So it's moving quite slow. And as you can see, each conflict between the gas particle will cause the direction change, energy exchange, and bouncing between the walls. Those are achieved and managed by the program behind of the things. And again, let's display the current speed and also uh, the total kinetic energy as we want to calculate uh, with with our familiar with our equations defined in the backend. So uh, and it will display all the needed data as well again for the education purpose of a chemistry class. This is not perfect yet. I'm trying to apply more functionality and more calculation, the better enhanced way to handle this thing. I would like to continue working on this project within my 699 if it is feasible. All right. Thank you for listening. That's it. Bye.